Good day everyone, we are students from STISK3013 Statistical Inference. In this video, we are going to see about hypothesis testing and empirical weight analysis. Now, let's meet our team members. I am Sankirtana Anabrampan Murugan and we have Noor Ayoni Shukuria binti Rusli and Mohammad Daniel bin Imran in our team.
Hello, my name is Nur Ayuni Shukuria. For the task 1, we conduct one sample test to determine whether the average initial weight of the student is significantly different from the historical mean of 68 kilograms. For the hypothesis, the null hypothesis states that population mean is equal to 68 kilograms, while the alternative hypothesis states that the population mean is not equal to 68 kilograms. Since we are testing for a difference, this is a two-tailed test. For the critical value, the significance level is 0.05. Since this is a two-tailed test, we divide it by 2, giving that 0.025 for each tail. The degrees of freedom are calculated as the n minus 1, which is the t minus 1, equal to 29. Based on the t-table, the critical value is plus or minus 2.045. For the test statistic, the sample mean is 71.073 and the standard deviation is 30.550 and the standard error is 2.474. Using these values, the calculated value is 1.242. For the decision, since the t-value of 1.242 lies between negative 2.045 and positive 2.045, we fail to reject the null hypothesis. In conclusion, there is insufficient evidence to conclude that the average student weight differs significantly from 68 kilograms at the 5% significance levels.
Now, let's see task 2 two sample independent t-test. First, we define the hypothesis. The null hypothesis states there is no difference in the mean weight between the two groups. The alternative hypothesis states there is a difference in the mean weight between the two groups. So, since we are testing for any difference either higher or lower, this is a two-tailed step. So next, we identify the sample statistic for both dataset. For the dataset A, sample size n is 30 students, sample mean is 71.07 kilograms, sample variance is 183.61. For the dataset B, sample size is 30 students, sample mean is 70.80 kilogram, sample variance is 161.56. These statistics will be used to calculate the pool variance and the test statistics. Our next step is calculate the pool variance. This is because the question states that the population variance are equal, so we use the pool variance formula here. So here we can see the formula and the defined value for the both dataset A and also dataset B. So once we substitute all the values inside the formula, finally we can get the pool variance which is 172.59. So next we calculate the standard error. The standard error measures the variability of the difference between the two sample means. So here we can see the formula for the standard error. And once we substitute the values inside the formula, finally we get the standard error which is 3.39. Now we calculate the t-statistic. The t-statistic tells us how many standard errors the observed difference in sample mean is away from the zero. So here we can see the formula. When we substitute the value from the mean of dataset A minus by mean of dataset B divided by our standard error, finally we get the t-value which is 0.08606. So this means the observed difference of 0.27 kilogram is only 0.0806 standard errors away from zero, which is extremely small. So next step is determine the critical value. The degrees of freedom are calculated as sample size of dataset A plus by dataset B minus by 2. So finally we get the degree of freedom which is 58. So using the t distribution table for alpha 0.05 and degree of freedom 58, the critical value is 2.001. So any calculated t-value beyond 2.001 would indicate a statistically significant difference between the two means. Now we make the decision. The decision rule is reject hash null if p-value is greater than 2.001. Otherwise, we fail to reject the hash null. Our calculated t-value is 0.0806. Since 0.0806 is less than 2.001, we fail to reject the null hypothesis. This indicates that the difference between the sample mean is too small relative to the variability in the data to be considered statistically significant. In conclusion, at the 5% significance level, there is insufficient evidence to conclude that the mean weight of students in dataset A differs from the mean weight of students in dataset B. Although dataset A has a slightly higher average weight of 71.07 kg compared to the dataset B which is 70.80 kg, difference of only 0.27 kg is not statistically significant. Therefore, the average weight of the two groups can be considered statistically similar.
Assalamualaikum. Today I want to present about task 3, paired sample t-test. First, determine the hypothesis, which is null mu equal to 0 and hypothesis alternative is h1 mu not equal 0. Next, compute each difference, the initial minus after the calculation, and the sum is 30.1. For the mean difference, 30.1 divided by 30, answer is 1.0033. Next, calculate the standard deviation. The standard deviation, the answer is 1.8444. Next is calculate the standard error, SE, and the calculation is 1.8444 divided by square root 30, and the answer is 0.3367. Next is calculate the t statistic. The t statistic is 1.0033 divided by 0.3367, and the answer is 2.9798, and the df is 30 minus 1, and the answer is 29. Next is decision, with the alpha is 0.01 and df is 29. The t critical is plus minus 2.756. Since 2.9798 is bigger than 2.756, we conclude to reject the H null. Also, the p-value 0.0058 smaller than alpha 0.01, so we can conclude we reject the H null. And the last conclusion, at the alpha 0.01, there is a sufficient evidence that the 3-month supplement program is significantly changed student weight. On average, student lost 1.0033 kilo. That effect is significant at the 1% level.
That's all from us. Thank you for watching.